An astronomer notes that a star of right ascension 3 hours and 45 minutes is crossing her meridian in the south. What is the astronomer's local sidereal time at that moment? This is a nice simple question because we know that the local sidereal time is the same as the right ascension of a star that is crossing their meridian. So therefore, if the right ascension of the star is 3 hours and 45 minutes, that'll be the same as the local sidereal time. So the local sidereal time will be 3:45. The right ascension of Regulus is 10 hours and 8 minutes. What is the local sidereal time of an observer who sees Regulus crossing their local meridian? And again, similarly to the last question, the right ascension will be the same as the local sidereal time. So therefore, the local sidereal time will be 10:08. An observatory clock indicates that the local sidereal time is 08:50. What is the right ascension of a star that is crossing the local meridian of the observatory? So similarly, the same as the previous questions, but in reverse this time. So we know the right ascension of a star that is crossing a local meridian will be the same as the local sidereal time. So the right ascension will be 8 hours and 50 minutes. Calculate the hour angle of a star that has a right ascension of 3 hours and 40 minutes and the local sidereal time is 5:15. So now we're going to have to use our equation, and we know our equation that the hour angle equals the local sidereal time minus the right ascension. So the local sidereal time is 5:15, and we want to minus the right ascension, which is 3 hours and 40, to give us our hour angle. So if we work that out, we'll get 1 hour and 35 minutes. A star with a right ascension 12 hours and 30 minutes crosses the local meridian of an observer 1 hour and 25 minutes ago. Calculate the observer's local sidereal time. So again, we're going to use the equation that the hour angle equals local sidereal time minus the right ascension. But this time we want to work out the local sidereal time. So we want to move the right ascension over. So we do the opposite. So instead of subtracting, we will add them. So we know that the hour angle plus the right ascension equals the local sidereal time. So the hour angle is 1 hour 25. I'm going to add that to the right ascension, which is 12 hours 30. So doing that will give us 13 hours 55 minutes. 1 plus the 12 to give the 13. 25 plus the 30 gives us 55. Okay, in these next questions, you need to calculate the right ascension and hour angle of stars alpha, beta, delta, and epsilon. So we'll start off with alpha here. So to calculate the right ascension of alpha, we literally just work it out down to the axis. So you can see that it has a right ascension of 23 hours. And the hour angle will be the time difference in crossing our meridian, but we can see that it's on our meridian, so therefore the hour angle will be 0. For beta, again, we've got to work out the right ascension. So the right ascension will be, just go down, so we can see that it's 22 hours. And then we need to work out the hour angle. So the hour angle is the difference between the right ascension and the local sidereal time. So the local sidereal time is 2300 hours and the right ascension is 22. So therefore we will do 23 minus 22, which equals 1 hour. So here we have star delta. So again, we need to work out the right ascension. So if we go down to the axes here, we can see that it looks just below halfway between 0 and 1. I reckon halfway is just about there. So I'm going to say it's about 5 minutes before that. So therefore it has a right ascension of 0025, so 25 minutes past 12. And then again, we need to work out the difference here. So the difference will be the right ascension, which is 0025 minus the local sidereal time of 23, will mean it's minus 1 hour and 25 minutes. And finally, epsilon, star epsilon over here. So again, drawing our line down, I reckon that is around about 2150, much closer to the 22 side. So it has a right ascension of 2150, and the time between there, well, that will be 1 hour and 10 minutes, and that will be positive because you can see there it's already past the meridian.